Can you see the PPT now?
Yes, sir.
Okay, fine. So in the previous class, up to previous lectures, we have seen that how to do the analysis problem and design problem. So in the case of analysis problem, we will be basically required to calculate the moment of resistance of a given section, right? So the basic procedure was, first of all, we have to find what type of section it is, that is whether it is a under reinforced section, balanced section, or an over reinforced section, and based on that we can have different formulas for calculation of moment of resistance. And similarly, we have also seen how to do the design problems, step by step procedure for that. So basically in the initial part anyway, you have to factor the load, multiply the working load with respect to load factor, and convert that to design load, or in other way you can just calculate the maximum moment that can come in the working condition and convert that to factored moment also. After that, what was the procedure? So basically we will assume the B, width of the beam based on the conditions, or we will directly assume it as a 250 or 300. After that, we will use the moment of resistance equation corresponding to moment of resistance of a balanced section, and we will find out the required D. Okay, basically we have the moment of resistance now, because that will be substituted as the external moment, and based on this the only unknown in that relation will be our D, and from that we can find out the value of D, and the corresponding steel required, if it is a balanced section, can be calculated with respect to the critical percentage of steel relation, or we can use the relation for finding out neutral axis depth also. Only thing is that you have to, instead of XU by D, you have to substitute it as X limit by D, and again X limit by D can be taken from your IS 456 page number 70. Okay, and if you want to design it as a under reinforced section, what was the procedure? Basically the initial steps remain the same, and we will be calculating the depth. After that we will be providing a higher value for the depth, then we will use the equation corresponding to under reinforced section, and we will design the section. Anyway, we will see these things, so while doing the problems the concept will be more clear to you. So let's take one problem. So I will just roughly explain how to do these problems. After that you can do it yourself. Okay, so if there is any doubt, you can just stop me and ask. So basically our first question is, let's see what the first question is. So basically the question is like this: you have to find the moment of resistance of a singly reinforced beam. Yeah, have I explained about singly reinforced beam? What do you mean by singly reinforced beam? Say for the time being, you just understand, say suppose we have a section, a rectangular section, normally where we will provide the reinforcement, main reinforcement at the tension zone, right? Normally if it is a simply supported beam, the tension zone will be at the bottom, so we will be providing the reinforcement in the bottom itself, right? And such a section in which the main reinforcement are provided only at the tension zone is called as singly reinforced beam. We have another type of sections called as doubly reinforced section. So only difference is that we will be again providing reinforcement in tension zone as well as on top of the beam, compression zone also. So in a later stage we will see why we want to provide such thing in the compression zone. So mainly we intend to provide reinforcement for taking up the tensile stresses, but in certain cases we will be in lack of resistance against compressive stresses. So as a support for our concrete, we will again provide steel in the compression zones also. So that type of sections are normally called as doubly reinforced section. Anyway, in the coming modules we will be dealing with that in detail. So for the current problem, you just understand that our section is having main reinforcement only in the tension zone. Okay. So coming back to the question, so we have to find the moment of resistance of a singly reinforced beam of 200 millimeters width. Basically the width of the beam is given as 200 millimeters. Then we have 400 millimeter effective depth. The depth is also given. So basically the dimension of the concrete section is directly given to you. Then it is also mentioned that it is reinforced with 3 bars of 16 millimeter diameter. So in the tension zone we have 3 bars having a diameter of 16 millimeters, and also the grade of the concrete is given, that is of 415 steel. Fe 415 means the yield stress of, or the strength of the steel is 415 MPa, and it is also mentioned that you can take M20 concrete. So the grade of concrete can be assumed to be M20. So these are the data given in the question. So how to do this? That is the briefly I have given some steps below. That is first in the first stage what you have to do is that once you get a problem like this, you just see what all data is given in the question. So if you refer this question, we have the dimension of the concrete section. That is we have the value of B as well as the effective depth small d. Okay, then we have the value of AST. AST means the amount of or the area of steel provided in the tension zone. It is mentioned that we have 3 bars of 16 millimeter diameter. Therefore, your AST will be equal to 3 times 5 by 4 into 16 square. Okay, then we have Fy value. Fy is 415. Then we have FCK value also, that is 20. So these are the basic data given in this particular question. Okay. Now to start with, as we explained earlier, the first step is to find out what type of section is this, whether it is an under reinforced section or an over reinforced section or a balanced section. So basically for that what we have to do, we have to actually calculate the actual neutral axis depth, that is the value of XU by D. Then you have to get the value of x limit by d, that is the limiting neutral axis depth, which can be taken from a table given in IS 456 page number 70, and you have to compare these two values. Suppose your actual neutral axis is less than your limiting neutral axis, it will be under reinforced section. Suppose these two things are equal, it is a balanced section, and on the other hand we will be having a over reinforced section. So once we finalize the section, use the corresponding equation and calculate the moment of resistance. So these are the steps for doing such a problem. This is a simple small problem actually. So let's see how this thing will turn out. So as the first step, I have just written AST. I have calculated AST and I observe it to be 603.19 mm. Then I have my Fy value, that is 450 Newton per mm square. Then I have FCK, which is 20 Newton per mm square. Then I have okay, these are the main data given. Then I have B as well as D given in the question. Okay, so as the first step what I am doing is that I am just calculating XU by D value, which is given by 0.87 Fy AST by 0.36 FCK into BD. This relation we have already derived this relation. So once I substitute the value of Fy AST FCK B as well as D, which are given in the question, I will obtain my value of XU by D as 0.3781. Okay, so in this particular case, my actual neutral axis depth is coming around 0.3781. Now what should I do? I have to just get the value of x limit by d from the table given in IS 456. So if I refer, if you have your IS 456 code with you, please do refer this and find out the value. Okay. So if I go to page number 70, I can see that there is a table given there corresponding to each grade of steel. We have different value of x limit by d. So in this particular problem, I have Fe 415 steel. So when you take the corresponding value from that, you will get it around 0.4791. I think in the code it is given as 0.48. So you can directly use that value also, not an issue. Anyway, here I have obtained this value means because we have the equation for actually calculating x limit by d. Anyway, I haven't shared that thing with you. That is not necessary actually. Actually, in practice, we will be directly taking the value given in the code itself. So if you use that expression, you will get more accurate results. That's all. So anyway, the final result that you can get using the equation is 0.4791. And if you compare these two values, we can finalize the type of section. And if you see here, this x limit by d is coming as 0.4791, which is greater than the actual neutral axis depth. That means the actual neutral axis depth is less in compared to our critical neutral axis depth. Therefore, our section must be a under reinforced section. This thing we have already seen while defining under reinforced section. For under reinforced section, the actual neutral axis depth will be less in compared to that of a critical section. So once we finalize this is an under reinforced section, what we can do in order to calculate the moment of resistance, we have the equation moment of resistance is equal to 0.87 Fy AST into D into 1 minus Fy AST by FCK into VD. You just substitute these values, all the values are known to you, and you can see that the final value obtained in this problem will be 73.48 kilonewton meters. So basically for a section having the provided B, D as well as AST, we can have a moment of resistance of 73.48 kilonewton meters. So I hope it is clear to you. Any doubts? or any area where you need further clarifications for anyone? So shall we proceed to next problem? I will give sufficient time for you to do this. Anyway, can we move on to the next type of problem? I hope it is clear to you. So I'm just moving on to next one. So let's see what is the next problem. So in the second problem, again we are supposed to find out the moment of resistance of a singly reinforced beam of again 200 millimeter width and 400 millimeter effective depth, but it is reinforced with 4 bars of 16 millimeter dia, again of Fe415 steel, and we are supposed to take M20 grade of concrete. If you compare this problem with the previous one, the only difference is that here we have 4 bars, whereas in this case we were having only 3 bars. So let's see what will happen in this case. So again, I am repeating the procedure. I am just checking the data given in the question. Then I will be calculating the actual neutral axis depth, which is given by the same expression. And in this case, since the AST is different, we can see that the actual neutral axis depth is coming as 0.5041. Now what I should do? I have to get the value of x limit by d. And again, we have already calculated that in the previous case. So, or we can take it from the code itself, therefore the value will be 0.48. And if I compare these two values, I can see that the limiting neutral axis depth is less than the actual neutral axis depth, or in other words, the actual neutral axis depth is greater than the limiting neutral axis depth, which shows that the provided section is an over reinforced section. So what we should do in such a case, and as per our code, we are supposed to redesign the section. We are not recommended to use an over reinforced section in practice. So therefore what we should do, we have to actually limit the maximum capacity to that of a balanced section. That is what we will be doing in this case. So what basically we will do is that our moment of resistance will be calculated using the equation corresponding to that of a balanced section. Clear? So we cannot use an over reinforced section, so we are supposed to design it as a balance section. So what we will do, we will just use the equation corresponding to a balance section, and for that the equation is like this: mu limit, or the moment of resistance corresponding to a balance section, is equal to 0.36 FCK x limit by d into 1 minus 0.416 x limit by d into bd square. And this equation also we have already seen. Okay, and if you substitute the values, you can see that the moment of resistance will come around 88.37 kilonewton meters. Now we obtained the capacity of the respective balance section. Now we need to do one more step, that is the redesign part. So basically, keeping the B and D as the same given in the question, we will recalculate the value of AST. And please note, you can do this by two methods. One is by using the equation corresponding to limiting percentage of steel. Another one is by using this expression, that is the expression for neutral axis depth, and here I have used the second case. And so instead of xu by d, I will be substituting x limit by d, and right hand side remains the same. And from this the only unknown will be AST, and from this total expression I will calculate the value of AST, that is the redesign part, and I can see that it is coming around 764.33 millimeter square. In comparison to that one provided was 804.25. So it resulted in an over reinforced section. So we restricted the capacity of the section to that of a balanced section, and finally we have performed a redesign, and we have reduced the amount of steel to 764.33 millimeter square, so that the resulting section will be a balanced section. Is it clear? Is the procedure clear on how to analyze a balanced section? No, or an over reinforced section? So basically, the initial steps were same. We just calculated the actual neutral axis depth, then compared with the limiting value, and we observed that it is a over reinforced section. So we have to restrict the maximum capacity of the given section to that of a balanced section. So we used the equation corresponding to a balanced section and found out the value of moment of resistance. And then what we have done is we have recalculated the value of AST using the expression for balanced section. So that is what you should do when you have a over reinforced section. In most of the examination, your university examination, one question will be there from this area. Okay, basically problems are very less in your first module, so you can always expect a problem like this. Mostly it will be a over reinforced section which have a redesign part like this. Okay, simple problem, maybe asked for 5 or 7 marks, that's all. So now we have one design type of problem also. So I hope the concept is clear to you. Any doubts in this, in the second problem, for anyone? Anyone is having any doubts?
Yeah. Clear, sir.
Clear. So I am assuming that it is clear for all. So let's move on to the design type of problem and let's see what we have to do here. So please see this question. So you cannot expect only these type of design problems from your first module, not the complete design. Complete design means you have to perform limit state of collapse, check for limit state of collapse in flexure, shear. Then you have to also perform limit state of serviceability corresponding to deflection also. So those things we will be dealing the actual design in a later stage. So as of now, you will just have a glance on how to design, how to what a design type of problem will be in perspective of limit state of collapse in flexure. So basically the question is like this: design a balanced, singly reinforced concrete beam section for an applied moment of 60 kilonewton meters. So please listen here. Please understand that it is given in the question as it is an applied moment of, that is actually we are having a moment value of 60 kilonewton meters, or the actual loads which are supposed to be acting on our structure is producing a moment of 60 kilonewton meters. This is the actual case. So when we perform our design, we have to actually factor this value. That is, we have to use a factor of safety and we have to increase this value. We will be multiplying or taking a factor of safety of 1.5 and we will be multiplying that with this load, this moment. Okay, 60 into 1.5 and we will be taking that as our externally acting moment, that is for ensuring safety. Okay, so please understand that this is working moment and we have to convert that into a design moment while doing the design problems. Okay, now that is regarding the first statement. Then let's see what all things are given in this problem. So in the next statement, they have given the width of the beam is limited to 175 millimeter. Due to some restrictions, we are supposed to limit the B value or the width of the beam to an amount of 175 millimeters. Okay, so that is given in the question. Then we are supposed to use M20 concrete and Fe415 steel. And also please note, for your university examination, sometimes some data will be missing. Sometimes purposely they won't be giving some data, sometimes accidentally some data may be missing. So you cannot just neglect those questions or those questions by saying that the data is missing. What you are supposed to do is that you have to make reasonable assumptions and proceed with the problem. Otherwise you won't be getting any credits. So suppose mostly noted thing is that they won't be specifying the grade of concrete or grade of steel. That thing repeatedly happens. So in such case, you just mention a statement that assuming the grade of concrete and steel to be so and so, and proceed with the corresponding values. Okay, and anyway in most of the design question papers, you can see at the starting point itself there will be a statement mentioning that you can make reasonable assumptions if data is missing. So please note that and keep in mind. Now the width of the beam is limited to 175 and we are supposed to use M20 concrete and Fe415 steel. So what are the steps for doing a design problem? Let's see that. So as I told, the first thing is that once you have a working load or working moment, you have to convert that to design moment. That is, you have to factor the load or the moment. So basically our first step will be that find the factored moment or the design moment, which is represented by MUD. D stands for design. Then again what we need to do is that we have to find the limiting neutral axis depth value. So we can obtain that from our code itself. Then what we will do is that we will just equate the design capacity, that is 60 into 1.5 will give us some value that will be equated or that will be substituted in relation for moment of resistance for a balanced section. Okay, so once you substitute that, what you can do is that, see, I think it is better to explain with steps. So here we have MUD, that is calculated by multiplying 1.5 with respect to the given value 60, and in order to convert, and this is one of the major mistakes students makes while doing the problem. So please be very careful about the units. So our FCK and grade of concrete, other things are given in MPa, that is Newton per millimeter square. So it is always better to convert or do the problems after converting everything into Newton millimeters. So as the first step here, 1.5 into 60 into, since we are provided with kilonewton meters, we are just multiplying with respect to 10 raised to 6. And finally, we can see that our design moment will be 90 into 10 raised to 6 Newton millimeters. So then as per the second step, we are supposed to find out the value of x limit by d. Okay, that can be taken from the code, and I think for 415 grade it is 0.4, right? So we just obtain that value, then we will use the equation corresponding to balance section as we mentioned. So instead of this mu limit, what you should substitute, you have to substitute this value 90 into 10 raised to 6 here, and on the other side you can see that you already know the value of xck, you have the value of x limit by d, then again x limit by d, but and again you have the value of b is given as 175 in the question, and again if b is not given in the question, you just assume that, assuming the value of width of the beam to be say around 200 or 250, okay, and you can proceed. So b is also known to us, only unknown quantity in this relation is our effective depth d. So substituting all these values, you can find out the value of d. And sometimes when you perform your calculation, you will be obtaining some value like 431.25 or 431.05. Please don't represent it in decimals itself, just round it up, okay, and express with respect to practical view. Okay, so we have to provide this depth in actual structure. So please consider that and provide or write your final values. So there is no problem in converting this a 432. You can just convert that to 440 or 450 mm. What sort of difference it will make? Please visualize what difference. Suppose I am getting the value as 432 millimeters. Okay, that is 43.2 centimeters. Then I am just converting that to say 450 millimeters, 450 millimeters. That means basically I am converting that to 45 centimeters, around 2 centimeter or 1.8 centimeter is what I am increasing. Will that make any difference? Say for a beam which is present in your room, you are just increasing a 1.5 centimeter. How much difference it will make? So please think practically and adopt your values. And always it is needed, it is compulsory to convert that to a rounded value, upper value. Okay, so we can do that here if you want. And in the first module, since it is purely for understanding the theoretical concept, they have most of the textbooks, as well as in whichever material you refer, they will have just put the value they are obtaining. That is just for you to understand the concept, theoretical concept. But in practically, when you as a structural engineer, if you are giving some drawing, producing some detailing, you have to round it to proper values. So please keep that in mind. And in here, we are just after this calculation, we are obtaining it as 432 millimeters. Okay. So once you get this value, in the next stage, what we are doing is that we are just using this relation, that is the relation corresponding to a balance section. There is a reason for that. In the question, if you remember, we are supposed to design this section as a balance section. So that is the reason AST is calculated with respect to or using this relation, that is x limit by d is equal to 0.87 Fi AST by 0.36 FCK into B into D. Right now we know all other values. We know the value of x limit by D, we know the value of Fi, we know the value of FCK, we know the value of B as well as D which is obtained from here. Only unknown quantity will be AST, and if you calculate AST using this relation, you will be getting the AST that is corresponding to that of a balance section. Suppose you were supposed to calculate or design this section as a under reinforced section. What can be the difference in this? So let me see whether I have a problem on that. Yeah, okay. Anyway, we have a problem on that. So let's see in the next problem what changes will be there if we are designing it as a under reinforced section. So for the same problem, find the reinforcement required for the beam if the effective depth of the beam is kept equal to 500 millimeter. That is, at this stage, suppose normally while explaining the procedure for design of an under reinforced section, I have mentioned that up to this stage we have same procedure. We will be finding a d like this itself, and then we will be providing a higher value for the d, so that I can convert that to a under reinforced section. So here what they have given is like that itself. They have asked us to, so basically here what they have done is indirectly they have just increased the depth, and it is kept around 500 millimeters. So obviously the section might have converted to a under reinforced section, and we are supposed to calculate the limiting moment of resistance of this section. So basically this is not a design problem, right? So okay, so in this case, calculate the limiting moment of resistance. So I think there is some mistake in this question. Actually, you're supposed to say, let's take this as like this. So you are supposed to design this problem as a under reinforced section. So what do you have to do basically? So please don't get confused. So basically what you have to do is that you have to provide a higher value of depth here. Then you have to find out AST using the equation corresponding to that of a under reinforced section. So the equation was like this. Mu will be equal to 0.87 Fi AST into D into 1 minus Fi AST by FCK into B. Oh, that is what they have done here anyway. That was a mistake in the question anyway. So you are supposed to design it as an under reinforced section, that's all. So if you see here, we are using the same moment of resistance. Okay, moment of resistance is given as 90 into 10 raised to 6, which was actually the factored load, which was a factored moment that was acting on the section. We have already seen in the previous problem, it is 90 into 10 raised to 6. So after increasing the depth, we are just using the equation corresponding to that of a under reinforced section, which is mu is equal to 0.87 Fy AST into D into 1 minus Fy AST by FCK into BD. So from this expression, here also the only unknown quantity will be our AST, that is the steel reinforcement that we have to provide in our section. So after simplifying this expression, we can easily calculate the value of AST, and that is the AST corresponding to an under reinforced section. Is the concept clear? Is there any confusion in this? Right now we have defined, we have seen 4 problems, 2 from analysis and 2 from design. And I think pretty simple problems, right? Any doubts or any clarifications required here?
Sorry, final AST like 2 millimeter difference
Not at all an issue. And again, while we take up the entire design problem, I will just explain things in detail. So how you can round it off. After rounding it up, we will be further checking. We will be having many checks to ensure that the final section is the same as we have expected, whether it should be a balanced section or an under reinforced section. For that, we will be performing different checks in that. So anyway, at that time, I will clearly explain that. So for the time being, you just understand there won't be any and again, after changing 2 millimeter and all, there won't be any changes. Okay. So you just do one thing, you just note down the first problem and start doing it. Just try to do it yourself, and please tell me the final answer you are obtaining. I'm just projecting the slide. Please find the final moment of resistance. So are you able to do it? Are you getting any value? 73.48 into 10 raised to 6. So let's see. 73.48 into 10 raised to 6 Newton millimeters. Yeah, that's the right answer. So I hope there is no confusion in doing this. Direct problem and pretty simple steps. Only in 2 steps you can easily score 7 marks. Now what I want you to do is that please note down these problems and complete these things at home. Okay. So all of you please note the second problem. And please note down the final answer for that. So basically it will, please note, it will be a balance section, and you are supposed to limit the capacity, and after limiting the capacity you will obtain it as 88.37 kilonewton meters. This is the final answer for that, 88.37 kilonewton meters. And the revised AST will be 764.33 millimeter square. 764.33 millimeter square. Now you can note down the next problem. In this case, you will get your AST as 722 millimeters, around 720. Okay. And as the fourth problem, you just write like this. Please redesign the previous problem by taking an effective depth of 500 millimeters. Redesign the previous problem by taking effective depth as 500 millimeters. So in that case, you will be getting AST as 578 millimeter square, 578 millimeter square. So that's it regarding this.